and then rolling a die. Let's say you draw a card and you get like the Ace of Hearts, which is exactly what you wanted. It doesn't mean that you're lucky. It doesn't mean that you're going to have fantastic luck. You should do it right now if you roll a die. Luck does not exist in mathematics. That's a personal belief that some people have. But it is definitely not going to be true in any of the math tests, just so you know. Dependent events, on the other hand, do affect each other. Two or more events that affect each other. Like sleeping through an alarm. If you sleep through your alarm, better chances that you're going to be late. All right, independent or dependent. Selecting a king from a standard deck, not replacing it and selecting a queen from the deck. Independent or dependent, guys? Dependent, because it is not replacing it. Tossing a coin and getting a heads and then rolling a six-sided die and obtaining a six. Independent, has nothing to do with each other. One does not affect the other. Driving over 85 miles an hour and getting into a car accident. Dependent. Is it mean that if you drive over 85 miles an hour, you will definitely get into a car accident? No. Is it more likely? Yes. It does change your probability. It doesn't mean that it's guaranteed. Okay, your turn. Talk to your partner about example 5.
Tossing a coin and getting heads, tossing a coin and getting tails.
No, I was just writing your handwriting,
All right. Who wants to give me the answers to both of these for a prize? There's Play-Doh over there. Go for it.
A is dependent
Mhm.
and B is independent.
Correct. Go get a prize. All right, the multiplication rule. The probability of event A happening and, that's really a good word there, and B happening is the probability of A times the probability of B. So if you want something and something else to happen, you multiply the probabilities together. For example, 2 cards are selected without replacing the first card from a standard deck of 52 playing cards. Find the probability of selecting a king and then selecting a queen. There's that and word, which means that we're going to multiply. So it's 2 probabilities multiplied together. Wait, so what was the first one?
52.
Okay, so out of 52, but it's not 52 choices, it's a probability, so it's a fraction.
Oh,
4 kings, so I'm going to write king underneath this. This is 4 out of 52 times what?
4 out of 51.
4 out of 51, because we didn't replace the card. There's one less in the deck, which is 16 out of, do you guys remember how to multiply fractions?
No.
You multiply the tops and multiply the bottoms. So it's 16 out of 2,652, which if you divide those two numbers is 0.006, so 0.6%, yes. All right, your turn. Talk to your partner.
Who's tough?
All right. Who wants to give me an answer for this one for a prize? Go for it, Sawyer.
Your chances, or the probability would be 1 out of 12.
Okay, how'd you do that?
So you take, so you got heads and tails, so that's 2.
So 1 out of 2.
And then you got 6 for the 6-sided die, and then you multiply them,
Mm-hmm.
and then you get 1 out of 12.
Beautiful. Fantastic, wonderful, go get a prize. Okay, we're gonna do this one together. For the anterior cruciatic ligament, the ACL reconstructive surgery, the probability that the surgery is successful is 0.95. Is that good?
Yeah.
Yeah, 95%, that's good. Find the probability that 3 ACL surgeries are successful in a row. Okay. This one has to be successful, and this one has to be successful, and this one has to be successful. So that would be 0.95 times 0.95 times 0.95. If you don't have a calculator, go get one.
Grab me one, sure.
Someone's stockpiling them under here.
A stockpile of calculators?
2 of them went under the desk.
Neat. I gotta figure out which kid that is that's doing that. And aren't teenagers fun? That desk is what, 10 feet away from where you could put them away? If you multiply these together, you get 0.857. Now, is this true all the time? No. Why is that not true all the time? There is kind of a dependent factor we're not thinking about. The surgeon, right? You could have a really good surgeon who has a better than a 95% average. You could have a surgeon who's not having a great day, and they could botch all 3 of them in a row. Also, it depends on how much damage